The purpose of this video is to explain the importance of the Ardent board stiffener component of the SK series sockets. This video will also go into detail on how efforts in the PCB design up front are important to the functionality and ultimately the performance of the Amphenol Ardent Concepts socket when delivered. The key to Amphenol Ardent's success lies in our patented core technology. Our contact set provides the fastest, most electrically efficient connection thanks to the utilization of dual-sided compression mount technology. In our SK series sockets, these contacts are housed within the interposer portion of the socket. They are the electrical connection bridging the gap between the device under test and the PCB below. See Figure 1 for a display of the different components of our socket. Amphenol Ardent's contacts have two states, free length and compressed. When compressed, the wire forms of the contact touch down on one another and, through this wiping action, initiates an electrical short. The electrical short created in this compressed state allows for the shortest path possible for the signal to travel, resulting in industry-leading performance and speed. Therefore, planarity of the board is vital when using Amphenol Ardent's SK series sockets. To ensure total compression of the contacts evenly over the area of a socket, tolerances and callouts of our footprints should be followed. If not, contacts may be unable to reach full compression and performance could suffer. In some cases, slightly decompressed contacts may not touch their designated pads, causing an open. To avoid loss of signal integrity and performance, we ask our customers to adhere to the callouts designated in all of our footprint drawings. Figure 2 provides an example of a capacitor component layout that hinders the ability of the Ardent board stiffener to function properly. The orange outlines represent the bottom PCB component layout of a customer's board. When overlaid on the board stiffener, there is noticeably not a lot of room for any of the support bosses of the stiffener to contact the PCB. This is especially true in the center of the socket, where arguably the most support is needed. Figure 3 provides an example of a design catered to the customer's capacitor component layout. In red is a DXF of the bottom of a PCB. The stiffener pad supports are marked by the white lines, and as you can see, the supports are designed so that they do not overlap with any of the capacitors. We understand capacitors are important in high-speed environments, but when switching occurs at high speeds, noise is generated from the charging and discharging of capacitors. This can lead to problems up to and including complete circuit failures. Bypass capacitors store a charge released to the power line when transient voltage spikes occur. When laying out capacitors, it is important to leave space not only for the bosses of the stiffener, but also the solder overflow that can occur. We recommend a 0.76 millimeters worth of separation between the supports and capacitors. See Figure 4 for a sketch of a proper distance between capacitors and support.